Alright, so two thin coils with a radius of 3 centimeters are 20 centimeters apart. Both coils contain 10 loops of wire with a conventional current of 2 amps that runs counterclockwise when viewed from the right side. What is the magnitude and direction of the magnetic field located halfway between the two loops? Well, I've drawn the diagram here. You've got two loops. I've kind of tried to draw the conventional current going through it, going counterclockwise. There are 10 loops each, and this distance is 20 centimeters, and radius of 3 centimeters. So what I've done here is I've done a little bit of conversions. We know that the distance is halfway of 20, so that's 10 centimeters or 0.1 meters, and that the radius is 3 centimeters or 0.03 meters. So we know that the magnetic field of a loop is mu naught over 4 pi times 2 pi r squared I over z squared plus r squared to the 3/2 power. So the number, since we have multiple loops on this wire, we multiply that times n, and that's all there really is to it. And the magnetic field net is equal to the magnetic field of the first loop plus the magnetic field of the second loop. Now, we just plug these equations in for here and here. So you have in mu naught over 4 pi times 2 pi r squared I over z squared plus r squared to the 3/2, and the same thing, but this is all for the second loop. Since we already have the given values for the loops, we just plug it in, and then we have our magnetic net field. It's 2 times 10 to the negative 5th Tesla. But let's try something a little different. What would be the electric field at the observed location if the right coil was reversed? Well, since both coils have the current in the same direction and they're both exactly the same, if we flipped one of them, both magnetic fields would be pointing inwards, canceling each other out. So the magnetic field at the center would be 0.